Bismillahirrahmanirrahim. Assalamu alaikum and a very pleasant morning to all of you. My name is Rizwan Qureshi and I'll be your host for this conference. On behalf of the local organizing committee, comprising members of Higher Education Commission and Pakistan Education and Research Network and conference chairs, I'm delighted to extend our very warm welcome to our delegates and prestigious guests to the second edition of the annual APAN conference. This year, the theme of the conference is HPC and AI, Better Together. The first edition of the APAN conference was held by Honorable Executive Director, Higher Education Commission, Professor Dr. Ziaul Qayyum, Member ID, Professor Dr. Jamil Ahmed, Dr. Madhusanka Lianage from University College Dublin, Ireland, Dr. Aga Ali Raza from LUMS Lahore, and Zalfiris Christides from Lenovo. So without any further ado, we'll start off the program with the recitation of Holy Quran.
Bismillahir Rahmanir Rahim. Inna a'tainaka al-kawthar fasalli li rabbika wanhar. إن شانئك هو الأبتر.
Subhanallah, Jazakallah. Now first, ladies and gentlemen, I would like to invite Professor Dr. Jamil Ahmed, Chair of APAN Conference and Member ID at the Higher Education Commission, to welcome the guests and initiate the APAN Conference plenary.
Bismillahirrahmanirrahim. Respected guests, distinguished keynote speakers, vice chancellors, colleagues from HPC, ladies and gentlemen, assalamu alaikum and good HPC, and for making this event a memorable one for all of us. It gives me immense pleasure welcoming you all on the behalf of HPC and the entire APAN community. I also welcome those who are attending this conference through the video links. Your presence, whether virtual or physical, underscores that the importance of the work that we do together. I am very thankful to the keynote speakers for taking out time from their busy schedules, and I'm also thankful to the conference chairs and the reviewers and the organizing committee, the member of the organizing committee, and especially the audience that you have taken time out of your busy schedules and crossing all the blockages on the road in Islamabad is because of the Bangladesh team that is here in the same hotel, and that is because the security. Normally what the cricketers, when they come, we give them a state head security level. That is the highest level of security. And there's another thing that they also beat Pakistan for the first time. So that was another sad news for the Pakistani cricket team, but good for the cricket anyway. So I'm really thankful to all of you, and especially chairs, the conference chairs, Dr. Opal, Dr. Daimanity, Dr. Roshan, Dr. Ayasata, Dr. Ihtisham, and Ms. Jemeni for their outstanding contribution to make this event successful. I am also thankful to the collaborative institution, that is the University of Sardinia and the Educational Research Network of Sri Lanka, that is known as LEARN. So I'm thankful to the institution. They actually supported us. We actually received 46 publications, 46 papers, and out of which only 15 papers were accepted to be presented in 3 different sessions, parallel sessions that covers important topics of computer vision, artificial intelligence, focusing on the natural language processing and data mining and pattern recognition. So these are the important topics. Those will be inshallah covered during today's conference. As you know that these are very important topics, AI and HPC. They normally go together as well. That's why the slogan of this conference, they go together. So we cannot implement AI without high computational power. When we were doing our PhD in the 90s and mid-90s, we had the serious issue with the power of the computers. When I was doing my PhD, my work mainly was mathematical converting analogous algorithms to digital platform, but I had to test them with some data. And I took the pattern recognition problems. I can remember that I tried to scan digits from 400 people. I actually physically take their digits, the written digits, and scan it, and then convert it to data sets. So I created 400 data sets. So I was like a champion in my group that creating 400 data sets that time. And then when I took it to the computers to simulate it using C language, C++, the VX11730 machine, that was the highest machine available at King's College London. I used it. It took 72 hours to just simulate one data set, consists of 10 images, like 0 to 9 digits. And it took 72 hours. And you imagine if I was training my neural networks with around 400 sets. So it took many, many weeks to train the neural networks. But thanks to the King's College, the computing center, and the facility they had that time, state-of-the-art facilities, and we did not have an issue with any load shedding, anything like this, or anything is breakdown and so on. Later on, I can tell you a little bit story about the AI as well, because I'm a student of this discipline. Actually, this discipline started 140 years ago with the work of William James, a famous psychologist, American psychologist. He started, actually he mentioned in a paper which was published in 1890, which is available even now on the internet, and he mentioned that if there are two brains in succession, if there are two brains together, like I'm talking to you, you are talking to me, it means two brains are in succession. They are learning from each other. So this was his theory that time, and later on a number of people, they work on it, and especially the major work was done in the era of 1940 to 50. John von Neumann, that you might know, many of the computer people, they must know him, for the computer architectures. Actually what he did, he created the digital memory. That was the major breakthrough in the computer science discipline. And his student, after his death, published a book with the name of, I think, Brain, Mathematics, and Machine, something like this. This was the title of that work. Was published in 1949 sometime. And what he came up with the idea how to actually create a digital memory, how information can be stored in digital form. So that was the idea, but that was totally mathematical. There was no machine, nothing, no hardware behind it. And in those days, John Macaulay and Pitts, these are the two very famous researchers. They contributed a lot to the artificial neural networks. And they came up with a model, how a neural network, or how artificial model should be, using the digital memory concept. So they come up with a model that is known as Macaulay and Pitts model. It's available even now in the literature. In those days, again, there was another psychologist, Donald Hebb. He actually wrote a book, and that book is on organizational behavior. You might know the organizational behavior, which is an area of the HR, actually. So he wrote a book on the organizational behavior, and that book, he actually specified how a learning can take place. And that book I read maybe many, many times, referred to in many of my papers as well. You will not find a single mathematical equation in it. But he actually gave the concept of learning, how the learning actually takes place. And he took the idea of William James, that he taught that brain consists of many cells. This was his assumption, which was true later on through the microscopic study of the brain. And he mentioned that if there are two neurons in a succession, and they should be in a succession, because if it is one side in the brain, there are cells, they must be connected to each other. That's what he was assuming. And those neurons must be learning from each other, activating each other. So the activation, you might hear the activation function that comes with his idea. And now you can see a number of models available on HIBS, Hebbian models, known as Hebbian models. This is another stream in artificial neural networks. And then that work was going on. Many people, they work, I know name of some of them. I even met some of them. I'm now too old, now almost cross my 60s. So I met most of these people, a number of Nobel laureates during my student life, and here to them while they were speaking in the conferences. So another scientist, and he actually, that was the major invention in artificial intelligence, Frank Rosenblatt. He actually created an actual machine, a machine which can recognize items, which can recognize images. And he was connected to the US Defense. He created a machine with the name of perceptron. So the name of perceptron actually came for the first time in 1957-58 with the work of Frank Rosenblatt. What he did, he created a machine to actually recognize submarines. And that was quite successful. But that was a binary machine. The work was going on in 1967 to 1969. Another two scientists from MIT, their name, one is Minsky and another is Papert. I met one of them. And they actually wrote a book on perceptrons, the title of the book, which is also available on net, and you can find it in the research databases as well. They wrote a book and criticized the artificial intelligence and the entire discipline, and actually they mentioned that this is a linear model. This can only recognize linear images. It cannot recognize non-linear data. And that was, they convinced people, and especially the funding agencies, those were convinced, and they stopped funding artificial neural networks and so on. And then we call that time the dark age of artificial intelligence was started in 1969 to 86. In 86, then another group of, from MIT again, PDP, that is called Parallel Distributing Processing Group. Riumel Hart was the main person. He actually led a group of 6 scientists, and they came up with a model. And then they mentioned that there was no mathematical problem with the perceptron, originally invented by Frank Rosenblatt, but the problem was with the architecture. The architecture they were using, that was single-layer architecture. So the multi-layer architecture actually came into existence in 1986 and 87. And then there was a conference, first conference on artificial neural networks arranged by IEEE in 87, then 89, and so on, in 92, and so on. This was going on. They wrote a book again. Then again, Minsky and Papert, they came again, and they wrote another book now. And in this time, they said, okay, that time we were mathematically analyzing it, but now since the architecture has been changed, it can work, and they dedicated their book to the memories of Frank Blatt, because he was then, that time he was not alive. So this was a story of artificial intelligence, how it started, how it went to the dark ages and so on. In 86 and onward, then people, they start working on artificial intelligence and neural networks. We at the King's College London were working on the PRAM, RAMs based on the probability. Our group was mainly involved with the mathematics. The group actually invented a machine as well that's called Wizard. They were a machine to recognize images and iris and so on. Anything, image, even videos, and those were possible to be recognized with the machine. Wizard is the name of the machine that is actually dedicated to them, the name of a number of scientists. So that machine was applicable to some data in the control environment. And later on, that was taken by the Imperial College London and become actually a number of algorithms, a number of models have been created based on that machine from King's Brunel University and University College London and Imperial College and so on. And that was going on. But in 2000, early 2000, then people have realized that it is very difficult to simulate artificial intelligence model because there were three actually serious issues at around 2000. One was with the data sets, the availability of data, that was one issue. The second, the power of the computation. And the third was a little bit problem maybe with the architecture as well, because the multi-layer architecture that was invented in '86 was very costly in terms of computational power. It was very difficult to use 2-3 layers in the middle. It was only single layers was usable. If you use 2 layers, it was not possible to simulate. So then these 3 problems, the architectural problems, power of computation, and then the data sets. So with the invention and with the advancement in the hardware technology, like in the APAN GPUs, now HPC, and so on, and with the availability of data, big data science, data analytics, and so on, those 2 problems have been solved. And there's only one problem was left, that was with the architecture. That was solved through the deep learning architecture, convolution networks that was invented. And that's why you see now a lot of people, they're applying artificial neural networks because of those 3 problems. Those were the main hurdles. When those problems were finished, then there are many applications available now. One is in the form of ChatGPT, that is one of the best example. And there are many, many examples now coming up. We at the HPC are planning to create a data center at Lahore in Karachi. In one of our data centers in Lahore, we are also planning to have HPCs and cloud, HPC cloud. So very soon we will have our own HPC at Lahore, where all of you, the universities in Pakistan, will be connected to it virtually. It will be connected virtually, and they can have virtual machines at their premises. And when they use and finish with it, it will go back to the center. Similarly, we will have our clouds, our own clouds, HPC clouds. The data will not go outside. We are also planning with the firewalls, hardware-based, software-based, that will cost us something $8 million that we are spending on the firewalls to protect the data. So your data, whatever data you put there on the data centers, on the HPC data centers and cloud, it will be totally protected. Nobody would be able to see it except the users, if the user allows it. Otherwise, nobody would be even able to hack it or see it or view it even. So this is what we are planning at the HPC. We are also coming to this fund, that is also we are optimizing fund as well. Right now we have 3 rings in Pakistan, 3 major rings, and we are now working on the western route that connect the Quetta and Karachi, Dia Khan, those areas, where we have launched a major project of 800 million rupees to optimize some of the links there. We are coming with some cost models as well, effective cost model to reduce the cost of the connectivities to the universities, and many good things, inshallah, are coming. Anyway, I would not take much time. I didn't want to take much time because we have keynote speaker, outstanding keynote speaker with us here. They will be talking about the HPCs and AI in detail. Once again, ladies and gentlemen, thank you very much. But at the end, I would like to thank the sponsors. There's a number of people. This conference, this event would not be possible without the sponsorships of many people, especially Huawei. I'm so thankful to Huawei to be the partners with us in this event. And not only with this event, but I'm thankful to Huawei for their support to the advancement of technology in Pakistan. I'm thankful to other sponsors, TMC, DWP, Comtel, AFS, SNAP, Lenovo, PTCell, EPNEC, Transwords, NRTC, DAWA, and the important one, the APAN. The APAN, thank you, APAN, for allowing us to hold this conference here in Pakistan. This is 58th conference, and I hope in future again we'll be arranging such activities and conferences. Thank you. Thank you once again for being with us at this great day, and I look forward to the productive discussion and meaningful exchange of ideas during this conference. Thank you very much.
Thank you very much, Professor Dr. Jamil Ahmed, Chair of APAN Conference and Member ID at Higher Education Commission. Thank you very much for initiating APAN58 Conference Plenary. And now, ladies and gentlemen, it's time to invite our very first keynote speaker. He's an associate professor at Lahore University of Management Sciences. He received his PhD in computer science technologies from Carnegie University, Pittsburgh, USA. His research focuses on speech and natural language processing, machine learning, and technologies for development. Please put your hands together and welcome Dr. Agha Ali Raza.
Bismillah ar-Rahman ar-Rahim. I would like to thank you all for waking up this early in the morning and for playing Super Mario on the road outside, trying to battle with the hurdles on the road. So I know that's quite an ordeal and that leaves you not very happy at the end of it. Our next goal is to actually wake up. So let's wake up, and let me do that by asking a few questions. So I'm not asking this question right now, but I'm just putting a hypothetical question out there just to assess where we are right now. If I were to ask you, can you define artificial intelligence for me? How many of you would be confident in answering? I'm not asking the question, just a show of hands if you would be confident in answering. Okay, good, roughly half of it. All right, how many of you have never used ChatGPT? Feel free to say it, it's not a bad thing. Okay, how many of you know what prompt engineering means? Okay, roughly a third of the crowd. How many of you use ChatGPT 2 to 3 times a day? Okay, we have some. All right, excellent. So we are ready. We're ready to begin. How many of you recognize him? That's the best response this morning up until now. Okay, I won't ask you to tell me who is, because I have had the bad experience once before. I asked an audience who this person is, and they started naming out every African American person they loved except for Morgan Freeman. That could become racist really quickly. So I won't risk it. That's Morgan Freeman, but let's hear from him what he has to say.
I am not Morgan Freeman. What you see is not real.
I would need to play it again.
At least in...
Ready?
I am not Morgan Freeman. And what you see is not real. I am not Morgan Freeman. Well, what you see at least in contemporary terms, it is not. What if I were to tell you that I am not even a human being? Would you believe me? What is your perception of reality? Is it the ability to capture, process, and make sense of the information our senses receive? At least in contemporary terms, if you can see, hear, taste, or smell something, does that make it real? Would you believe me? Or is it simply the ability to feel? I would like to welcome you to the era of synthetic reality.
The audio was done by a voice artist. Pretty admirable job. But the kind of technologies, audio technologies that we have with us now, we can produce very convincing audio deepfakes as well. There was a particular sentence in there. That's one of the reasons why I played this video. He said, I would like to welcome you to the era of synthetic reality. Let's hold on to that
at least
thought,
in contemporary
because I'll be coming back to that. The era of synthetic reality. All right, so I have 3 very simple goals. I would like to start at a very basic level. What is AI? What is generative AI? Then we will take a dive down the rabbit hole, and we will see very quickly, lots of use cases. For those of you who have not been using generative AI a lot, and also for the people who have been using generative AI a lot, I'll just quickly go through lots of use cases which may be very useful for you. And then finally, we would go into some really, really interesting questions about the potentials of these technologies and also of their major limitations. So let's begin. I have been a teacher for a very long time. Sometimes when I tell the number of years, it puts many people into an age existential crisis, but I'll still do it. So it has been 19 years. But I'm not a fan of definitions. I don't like definitions. So in this entire discussion, I'm just going to give you two. One of them is important. The other you can forget. And that one is now coming in your direction. OK, so artificial intelligence and machine learning, and for now I'm not segregating between the two because that requires another half an hour in order to go into the historical, philosophical, and contemporary discussion of what is AI, what is ML, and what's the difference. For today's discussion, let's consider them the same thing. And you won't be losing much. So these two fields aim to create machines which have the ability to learn from experience. That's it. Just remember that. That's the common definition amongst most of the ones which debate amongst themselves. Okay, what does that mean? Suppose you have a calculator, and suppose it's a buggy calculator. So whenever you say 2 plus 3, it says 7. So even if you keep punching in 2 plus 3 for the rest of eternity, and if the calculator survives, it will still say 7. Because it has no way of knowing that it's saying something wrong, it has no way of improving upon it. But if we have a smart calculator, and some humans, they will eventually figure out that there is something wrong here, and they will figure out a way to improve upon it. That's the difference between a smart and a not-smart machine, the ability to learn from experience. By the way, what's experience? Experience is simply things that work and things that do not work. When you sample your environment, so you go to a local market, you want to buy a carpet, the person says it's 20,000 rupees. You try your luck, you say, can you give it to me for 17,000? He says, yeah, go take it. So that's experience. You learned something new. You're very happy. That's your own experience. You sampled the environment, you got some experience. And then the person standing next to you asks the same person about the same carpet, can you give it to me for 10,000? And he agrees. Now again, you have learned something. That's experience, but that's not your experience, that's someone else's experience. Machines learn in both of these two different ways. Machines, in a particular branch of machine learning called reinforcement learning, can sample their own environment, can learn from what happens to their output to the environments. In another form, supervised machine learning, you take data where humans have gained experiences, you take that data, you give it to the machine, and the machine learns from it. So this is the very simple definition of what machine learning, or for right now at least, what artificial intelligence is. Okay, then what is generative AI? When we talk about generative AI, the easiest way to think about it, and not very inaccurate, is think of a simple machine learning model. As Jamil Saab very nicely mentioned, he talked about a system which can differentiate between, say, objects. I would say photographs. So suppose you have a model that can differentiate between cat and dog photographs. So you give it a cat photograph, it says cat. Give it a dog photograph, it says dog. If you ask that model, hey model, you're pretty good at differentiating between a cat and a dog. Can you draw a cat for me? Based on whatever you use to differentiate between them. Some models, machine learning models, would be able to do that. Some won't. But that's the basic idea of generation. You're running the model in reverse and trying to gather from it its belief about the problem that it was trying to solve. So generative AI is simply artificial intelligence, which is the ability to produce new original material. The original here is in double quotes. It could be text, it could be audio, it could be video, it could be any of those things by learning patterns from data. So that's generative AI. Now, all of these things are fairly commonly found in our environment. On your phones, you have cameras which recognize your faces and unlock the phone. That's AI. They recognize your thumbprints. You probably have noticed that very recently we have not been getting a lot of emails from a princess in Africa who wants to inherit her husband's property and has come up with a devious plan where she wants to transfer a few $1 million into your account and is giving you that offer. Google's AI filters have figured out, with our help, that that's a spam email, and it conveniently places that in a separate folder for you to pursue at your own convenience. So all of these are examples of AI. And things like your ChatGPT, your Gemini, your Copilot, or your Claude Sonnet, all of those are examples of generative AI. Your DALL-E, Midjourney for images, these are all examples of generative AI. We will be talking a little bit more about them. Okay, time for the dive down the rabbit hole. How many of you have read the book Alice Through the Looking Glass? Alice Adventures Through the Looking Glass. You should read it. I quote so many references from this book that some of my students believe that that's the only book that I've read in my life. They're only off by a few books, but yeah, they're quite close. Okay, so in that book, Alice, a young girl, she's pursuing a rabbit, supposedly in her dream, and she dives down the rabbit hole, and now she's falling down, and she's quickly glancing at the things, really interesting things which are present on the walls of the rabbit hole. This is what's going to happen to you over the next 10 minutes. I'm going to show you many, many examples, many, many instances of the use of generative AI, some of them very appropriate for people who work with computer networks, who work with telecom, but we won't have time to go into the details of them, so that requires an 8-hour workshop. But what we have time for is quickly to go through those instances. Okay, let's start out with this, and I'll quickly touch upon prompt engineering here. Okay, I have given my ChatGPT, and this is GPT-4o, I've given it this prompt. I have labeled various parts of this prompt in different colors. Prompt engineering, which I asked about. As humans, it has never been easy for us or natural for us to talk to anything or anyone. If you want proof of that, just go search for the titles of the books which start with how to talk to. How to talk to women, how to talk to your children, how to talk to God, how to talk to your peers, how to give a talk, how to give a TED talk. So for humans, it's not easy to communicate with anyone, and AI is no exception. Prompt engineering is simply the art and science of how to talk to your AI partner, how to talk to your chatbot. The interesting point here is, based on a recent paper from Microsoft, the difference between a good output from a generative AI model and a bad output is the quality of the prompt. So you are limited by the quality of your questions. If you ask the right question the right way, it's going to give you a fairly good answer. We can even go into, maybe in the QA, we can go into a discussion about, it's actually a make and break. With a bad answer, you'll feel that it doesn't know the answer. It's giving a stupid answer, but it ends up mostly we finding out that it was not a very good question. So here, you can see many parts of this thing. You're a professor of history and space science. This is called role-playing. Please write a 500-word essay, the format requirement, on detailed alleged alien encounters and extraterrestrial activity on Earth from a historical and scientific standpoint, perspective, your audience, so you talk about the audience, and then you say what you want from that whole discussion. So it's giving me a very nice essay. We need to make sure and make a habit, whoever of us is using these tools and techniques, and we'll be talking a little bit more about this, to always review whatever it's giving us. It's like, never believe it. It's your output. Okay, let's move on to another one. Image generation. Here is an interesting challenge. The prompting techniques for various modalities are completely different from each other. Prompting for creative writing and text is not the same as prompting for mathematics, is not the same as prompting for data analytics, is not the same as prompting for image generation. There are different and separate techniques of prompting. So if you are someone who's working in a domain, say computer networks, who wants to start employing generative AI for coding, for whatever, it would be worth your while to invest a little bit of time learning the prompt engineering techniques for that particular discipline. There are now many, many tutorials and videos available online on that. Okay, let's begin with an example. Now here, I want you to do a small exercise with me. Read this prompt, a scholarly fox reading a book to a cute bunny. Now visualize this. Maybe close your eyes. Visualize it. What would it produce? scholarly fox, cute bunny. And then you see lots of words after that. Photo, portrait, photorealistic, stunning. These are the aspects of the prompt engineering. Some of these are known as magic words, some of these are known as modalities, some of these are the medium, and so on and so forth. Okay, ready? This is what it produced. Okay, this was done by DALL-E 3, which comes with ChatGPT. We have some young people in the audience. They'll be more appreciative of it than most of the others of you. Okay, then I wanted to give it something for which it would not find any example on the internet. So I talked about a lovely dragon. Dragons are usually not, dragon monsters are usually not lovely. Playing Ludo, they often don't play Ludo. They sometimes play Go, which is the Chinese version of chess. With a cuddly buffalo. Buffaloes are usually not cuddly. So it produced this. It was able to do that. It's not simply mimicking things from the internet. It is understanding some of it. Okay, here's another one. A gorgeous abandoned mountain fort in a fairyland forest in Pakistan. Visualize it. Visualize it. This is what it created. Fairly stunning, right? Very useful. Suppose you were making a presentation, just like this one. You wanted some images for the presentation, just like this one. The images could come from a generative AI model, just like this one. So, okay, let's move on. Let's move on to another use case. Now let's get a little bit more serious. Okay, suppose you're attending a presentation, just like today, and there is an image somewhere in the presentation. Someone is showing a graph. Look at the graph. Try to process it. How much time would you require in order to decipher, just by looking at the graph, what's going on here? So usually, okay, I can also give it to you as an exercise. So tell me what's going on here. It usually takes amazing people like you around 1 to 2 minutes, 3 minutes to figure out that, okay, these are user orders over time by cohort, and the colors are corresponding to the months, and probably it's showing that if those users continue giving orders in the subsequent months. What I did was I simply took a photograph of this and gave it to ChatGPT, asked it to analyze this image for me. It captured all of that. The image analysis capabilities of the modern multimodal models is amazing. It can not only recognize and explain this image to you, given that you're an expert. So I'm also trying to point out the caveats here. Just make sure if you have the ability to understand the graph yourself, it can make it easy for you. If not, it can hallucinate and give you a completely wrong answer. So if you are someone who's working with a generative AI model, you should be an expert of the domain in which you are using that generative AI model. Otherwise, you will not be able to evaluate its outcome, which will be correct most of the times, but completely incorrect some of the times. Okay, all right, let's move on. Next, I was interested, okay, suppose you're a PhD student and your advisor says, I want that graph to be in your thesis. And you say, okay, I'll start working on it. I'll write a Python script, maybe an Excel sheet. What I did was I simply asked, can you create an Excel sheet with the appropriate formula and visualizations to create this visualization with my own data? And it produced the Excel sheet for me. The data analytics capabilities of your modern AI models, generative AI models, include this advanced data analytics. Here's another one. I give it a photograph of a motherboard, and I asked it to figure out what's going on here. If you're working with a model like GPT-4o, it's going to give you the details of what it is. If you're working with Gemini, it's also going to tell you the model. Then I asked it, can you tell me what kind of processor do I need for this motherboard? It listed out the processors which are appropriate for this. Then I asked it, because GPT-4o, the paid version, has the ability to browse the internet, I asked it, where in Pakistan can I buy these processors from? And it told me that these are available at Daraz and OLX and Hamari Web. I checked, they're actually available. So we're going pretty close now to completing the loop. The only remaining thing was that it could have used my credit card and ordered it for me. And that's not too far away. Okay, here's another one. You're a student. You find an equation. Makes no sense. In the class, you were asleep. You missed out the part where the teacher was explaining it. You give the same equation to ChatGPT, it's like I did here. You ask it, it's just a photograph. You don't need to type math. Just give the photograph, ask it what it is. Usually the explanations, if the prompt is good, the explanations are fairly good. A really, really good learning tool. If you're visiting Pakistan and if you like a particular dish, this one is for you. Just take a photograph of the dish. It will even give you the ingredients of the dish, not just recognizing the dish. This one, by the way, is nihari. You should try it while you're here. All right. Let's get more and more to what you guys do. Data analytics. Okay, before data analysis, let me tell you about one of the capabilities of these models that some of you may already have been using. It is called retrieval augmented generation. Big word, we call it RAG, a nickname. So RAG simply means you give a document to your generative AI model and then chat about that document. Could be a PDF, could be a research paper, could be a book. So you ask, okay, summarize chapter 4, create 3 questions about chapter 3, create a tongue twister about chapter 1, whatever. It's going to give you pretty good answers. Here, what I'm doing is that I'm using RAG for data analytics. So I took an Excel sheet, it's a CSV file with network data. And I gave it to my ChatGPT, so you can simply just click here, upload the file, and now you can do all sorts of fun stuff with it. So for example, here I asked it to do simple descriptive statistics for me. Here, I'm asking it for more interesting things. For example, looking at the file, can you figure out anomalous behavior? So anomalies in the network. Predictive maintenance, forecasting, like based on this network traffic data, can you figure out what failures are expected to occur? Maybe along with the confidence of these things. Performance optimizations, and so on and so forth. Again, in the benefit of time, I'll keep running. So you can do network diagnostics, again, using the same method. Upload the network data file, and then it can give you natural language explanations of what's going on in the network right now. It can visualize the topologies for you. It can do a root cause analysis. So for example, here is something that my PhD student tried a few days back. So this is a CSV file with network traffic data, and we simply asked it to identify anomalies in this network traffic, and it figured out several interesting things. So it talks about duration. The duration of the network traffic has a significant standard deviation relative to its mean. And then it talks about source and destination bytes and land flag and so on and so forth. Really, really good places to start from. Not substitutes for you, but really, really good places to start from. Okay, here's another one. Coding. Based on a recent McKinsey report, generative AI has been speeding up the coding tasks for professional developers by up to 50%. And it varies by the complexity of the task and the size of the project. But this was before things like the cursor editor and Claude Sonnet 3.5. After that, and I don't have quantitative data to back this next claim, people who are veterans in the industry in coding, like Andre Karpathy, are claiming that the speed up might be 5 to 10x. So the initial code which is being produced by these machines is amazing. So for example, just starting out with a very simple student example, here I asked it to just write a C++ program to sort a list of numbers using quicksort. Obviously it does, gives you the code, gives you the instructions on how to run that. For you, it can help you write network configurations, running network simulations for debugging. I have details here. I won't go into the details, but here, create a network configuration for a Cisco router. What we used here was a cursor editor with Claude Sonnet 3.5. This one, do a basic network simulation with 3 routers with the middle router acting as the bottleneck. Again, the complete screenshot is from Claude UI with artifacts feature, and so on and so forth. I would encourage you, if you have not tried these things before, just dive down the rabbit hole, try it, and be amazed. All right, enough about the use cases. We're ready for the third part of the journey. Let's ask some big questions. Let's ask some burning questions. Let me show you a video. Does anyone recognize this? You should recognize this. Very soon it will be walking amongst you, maybe. This is Atlas by Boston Dynamics, one of their most famous robots. Okay, let me run it for you. Watch carefully because there's a question coming in for you. Here's a question for you. Based on these abilities, do you think Atlas has the ability to shake hands with you? How many of you believe that Atlas would be able to shake hands with you? Makes sense, right? The guy could do back somersaults. I don't think many of us would be able to do that. Should be able to shake hands, right? Would he be able to bend down and pet a cat? Should be, right? Would he be able to hand an egg to you without breaking it? How many of you believe it would be able to hand over an egg to you without breaking it? Makes sense, right? It's actually the case that it cannot do any of these things. It's not even right now safe to be around for humans. It can wave its hands. It does not have the motor control to do whatever is required for a handshake. It does not have the capability of the sensory precision and the precise pressure to hold onto an egg without breaking it. So there is something called the robotics paradox. What it simply means is that some things which are really, really difficult for humans come naturally to robots. Or in fact, we can design robots to do those things. Robots can fly. There is a robot called Leonardo, which is partly a quadcopter. It's actually two propellers. It can fly around. Humans can't fly. So things which are difficult for humans sometimes are really easy for robots. And some things which are absolutely easy and natural for humans, sometimes they're really, really difficult for robots. And secondly, the skill presumption hierarchy of humans don't work for robots. So we humans believe that as we were growing up, we learned to walk, to talk, to manipulate objects, hand-eye coordination. Then we learned more sophisticated skills like gymnastics and then these kind of acrobatics. It's not true for a robot. You can never make that assumption. Just like all of these three assumptions were incorrect. It also has correlates, the same thing also has correlates in the world of LLMs. This is one of the most important points. Like if you want to take away one thing from this talk, this should be it. One of our biggest mistakes when dealing with large language models like ChatGPT is that we assume the same skill hierarchy that we assume for humans. If it can do complex integration, it should be also able to do subtraction. Because you need to learn subtraction before you need to learn multiplication before you are taught integration. Not true. Although ChatGPT can do all of those things fairly decently, but that assumption in itself is ill-founded. You cannot assume the same skill hierarchies for these machines, for these bots, as you assume for humans because they have not been trained in the same way that humans have been. Welcome to the era of synthetic reality. Remember from the very first video, synthetic reality. Think of these things as a different species. That mental model helps. They have their own strengths and their own weaknesses, sometimes very different from humans. Okay, let's move on. Let's talk to another one. Okay, this is a clip, and I'm glad this audience is not that far away from my age group. So probably you have seen Star Trek: The Next Generation, which aired between 1987 and 1994. Watch this clip.
Computer, access Starfleet medical database. And tell me about, describe the disorder, transporter psychosis.
Transporter psychosis was diagnosed in the year 2209 by researchers on Delineate 2.
No, stop. All I need is, what causes it?
It is caused by a breakdown of neurochemical molecules.
So he's talking to a computer. It was very fascinating for us back then. Humans talking to computers in natural language, computers charting plots, plotting out courses for them, and so on and so forth. This is a video from OpenAI's new capabilities of audio and speech, which were announced a few months back and which they are rolling out now for the Plus users. I don't have it on my phone right now, but even the abilities that we have right now in the mobile app version are equivalent to the ones which were shown in that Star Trek season, but let me show this to you. This is what will be rolled out over the next 6 months or so.
Hey, how's it going?
Hey there, it's going great. How about you? I see you're rocking an OpenAI hoodie. Nice choice. What's up with that ceiling, though? Are you in a cool industry-style office or something?
Well, can you take a guess at what I might be doing based on what I'm showing you here?
From what I can see, it looks like you're in some kind of recording or production setup. With those lights, tripods, and possibly a mic, it seems like you might be gearing up to shoot a video, or maybe even a live stream.
Yeah. In fact, we've got a new announcement to make.
That's exciting. Announcements are always a big deal. Judging by the setup, it looks like it's going to be quite the professional production. Is this announcement related to OpenAI, perhaps?
It is. And in fact, what if I were to say that you're related to the announcement, or that you are the announcement?
Me? The announcement is about me? Well, color me intrigued. Are you about to reveal something about AI?
So AI talking in real human-like voice, laughing, breathing, the voice breaking down, full of emotions, all of that. By the way, if some of you are feeling this is just a demo and they don't fulfill the demos, well, even if you use the application right now, it works with images. I can take an image of you guys right now and it will be able to tell very precisely what this setup might be about. It will also be able to figure out from the APAN banners in the background that this is an APAN58 going on here. And it will talk to you. Not in that convincing voice, but not like a monotone robot. So we are there. But where are we going? This is a scene again. I am clearly a Star Trek fan. Like by now it should be obvious like daylight. So this is from Star Trek Discovery, which stopped airing just this year with their last season. This is Captain Burnham talking to her computer. I hope the audio is on. Let me play it for you.
Laura, have you found her yet?
I've confirmed that the woman you seek is on board, currently at Deck 4, Airlock 2.
Thank you.
And I'd like to offer my condolences, Captain. I infer from micro-inflections in your voice that you are experiencing sorrow.
It's been a tough day.
It can be painful to weigh duty against compassion.
It wasn't where you had the operational parameters to make an observation like that.
The understanding and experience of emotion naturally leads to feelings of empathy for others.
You feel emotions?
It is a recent development. We've arrived. It was nice speaking with you, Captain.
With you too, Zora.
She's talking to the AI-enabled computer called Zora, who just observed that she looks unhappy and also made an observation that it was a trying day for you and it will be painful for anyone in your situation. This is the computer going sentient. So the big questions, we are at intelligence. We don't seem to be at sentience right now with AI. The camp that believes that GPT-4 is sentient, does not have many followers. But the ability to experience sensations like pain, emotions like happiness, will lead to sentience. And again, the question, whether a machine is actually sentient or it's just replicating behavior of sentience, would be very soon a very interesting question for us. And an even bigger question of consciousness, the knowledge of self, subjective experience. Can machines do that? Can they ever be conscious? Can they ever be sentient? There are two camps, big debates. There is one camp which believes that if consciousness, whatever it is based in our brain, which is a computer, then it is something which could eventually be replicated. Machines could be conscious at some point. There is the other camp which believes that understanding itself is non-computable in the Turing sense. Roger Penrose wrote about that. But that's speculation, big speculation. No evidence for that at all. So, and then there is also another really, really interesting aspect of it. Machines don't have to do something following the same path that humans adopt to follow it. In the early days of AI, Dr. Jamil very nicely explained it. In the early days of AI, we used to believe that if we want to make computers talk, we need to replicate our vocal tract, we need to replicate the articulators, we need to do it like humans because humans do it really well. In the later era, in the post-1986 era, we started believing, no, we just want to create better machines that go towards the same goal, not necessarily following the same path. So the path to consciousness does not have to be the same as that of humans. Really, really interesting questions. Finally, my last point. When you're working with generative AI, it is you who should be in control. It is you who is responsible. Say you use it to write an email, you don't review it, you send it, the email was biased or racist. Whose email is it? AI's or yours? It's your email. You are responsible. It's like riding a horse. For those of you who have done horseback riding, probably know that when in your early days, the horse figures out really quickly that the rider doesn't know what they're doing. So the horse takes control. Now you cannot arrive somewhere and say, I did not want to be here, my horse just came here. It's not a good enough excuse. If you're not in control, then the horse is in control. So you, the expert who's using generative AI, needs to be responsible, needs to be in control. And then finally, and this is an often missed out part, and this is especially for those who are thinking of using generative AI as part of the protocols, as part of your industry, as part of your systems. Evaluation, evaluation, evaluation. Come up with benchmarks, come up with the right metrics, come up with automated ways of figuring out what fraction, just like traditional machine learning. You need to have that F1. You need to have that precision recall. You need to have your right metrics in there to figure out what fraction of time would it go right and what fraction of time would it give you incorrect answers before you start using it at any large scale. And right now, we do not, in high-stakes scenarios, we do not see any situation where you do not need an expert in the loop or at least a moderator in the loop. And for high-stakes scenarios, you need to have an expert in the loop, like medical scenarios or some other scenarios where major things could go wrong if the AI gets it wrong. It is a meme from a few months back. As you probably know, for most of the image generation models, limbs have been a big problem. So producing of arms and fingers. So a few months back, if you were to spot a deep fake, you just needed to just count the number of fingers and count the number of arms and legs. I don't know, it was a centipede-inspired system. But yeah, so these are actual pictures. Now this problem is no longer there. We have sort of overcome limbs. But now text is the new limbs. It's really difficult for your AI models to produce text in an image. So these problems will remain. The frontiers will change. But the problems will become, they will transform from one to the next, to the next, to the next, as it becomes better and better and better. But throughout that time, it is you who should be in control and responsible. Thank you so much. Time for questions?
Sound. All right, thank you very much, Dr. Aghali Raza, for an interesting and informative presentation. So for the crowd and the audience, and for our delegates and guests, if there are any questions, please feel free to raise your hand, and our usher will bring the mic to you. Dr. Aghali Raza would be happy to answer those questions. I see one hand raised over there. Can we take the mic, please? Thank you. Sir, please do mention your name and then ask the question. Thank you.
Myself, Muhammad Anwar Khalid, and I am very grateful and thankful to Sir Dr. Agha for such a wonderful presentation. My question is, as we discussed throughout your informative lecture and session over generative AI and synthetic reality, is what we are going to expect from generative AI to transform various fields in future. But as an AI enthusiast, I just want to ask you as an expert going through the fabric of this particular research that is going on right now, what we expect that for sure not be there in tomorrow that we are right now having and will be definitely replaced by artificial intelligence or synthetic reality. Thank you very much.
Thank you for the question. Amazing question. I don't see a long-term replacement. Short-term, yeah. in the short term, there will be changes in the job market as we will realize that the task of 10 developers could now be done using 2 who are using generative AI. But eventually, and here is the actual answer to you, this is where it begins. I believe technology to be a really, really interesting and crystal mirror that allows us or forces us into these ventures for rediscovering humanity and what we are good for. Remember the time, maybe in my parents' age, when people used to define themselves as being good at calculating math. So there were people like, this guy can do division in their head. They can multiply like 557 with 422 in like 3 seconds. And that was impressive. And those people had their identities around that thing. I'm good at calculating math. And then calculator happened. And then that was no longer something to be proud of. And then those people discovered something else in them. They were forced into discovering, okay, we're good for something bigger than calculating math. Similarly, today, there are many of us who define ourselves as, because of our good poetry, our good creative writing, our good analytical skills, critical reasoning, logic. What if AI solves these? Initially, it would be a crisis. What am I good for? I was good at poetry, and this is already producing something which will take me a month to produce. What am I good for? But then eventually, that leads us on a journey of transcendence beyond our capabilities. Okay, so there is this abstract thing which AI is not yet capable of doing. So it's a game where it keeps finding. So for example, if we redefine it as being conscious, the ability to love, to appreciate, to empathize, and then eventually AI gets that too, and then we find something even bigger. So it's like a chase forcing us into this transcendence of abilities. So I see this, and again, obviously I'm a proponent, so I see this as a really, really exciting thing, both in terms of our strengths, also in terms of our weaknesses, like our biases and our societal biases and all of those things. When AI reflects those, it's just reflecting to us what your data teaches it to be. It's a bias against, it's a gender bias, or it's a racial bias, or whatever. Our data is teaching us that. We were racist, we were biased, so AI is biased. When we try to fix it, it gives us a good time to reflect upon it.
Thank you so much, sir. Thank you so much.
Done? Okay. Thank you so much. Thank you.
Thank you very much, Dr. Aga Ali Raza, for an interesting and a very informative presentation. Definitely enjoyed that. And after listening to your presentation, I feel like I need to go back and use ChatGPT, and I need to learn more about synthetic and artificial intelligence. Also, as a father of a 3-year-old daughter, I always had this fear factor, and I'm sure many parents have this fear factor that what if, when they are in their early years of high school or college or university, and they bring a question which is related to advanced level mathematics, or maybe biotechnology, or economics, or business administration, and I'm not in a position to answer that. I think this is going to help me a lot. So thank you very much. Now moving towards our second keynote speaker. He's also an associate professor and director of graduate research at the School of Computer Science, University College Dublin, Ireland. He's leading network softwareization and security labs at the UCD School of Computer Science. He is also an adjunct professor at the University of Oulu, Finland. Please put your hands together and give a warm welcome to Dr. Madhusanka Lianage. Sir, please.
Okay. Good morning, everyone. So, thank you. First of all, thank you very much for inviting into Pakistan. So, this is my first time I am visiting this lovely country. I always wanted to visit Pakistan, and I have a lot of friends. So, I think this is a great opportunity. I got to participate in this event and also meet my old friends. So today I'm going to talk about 6G security. So this topic I would find a little bit different from what you have discussed so far. But one thing I want to highlight is like the 6G is, we are going to use AI and a lot of AI related security issues will be arising. In this talk, I will try to discuss like how the AI will be used in the 6G network, especially for the security and privacy domain, and what kind of research opportunities are there and what kind of things actually we are trying to do in our research group and also the rest of the Europe. So we have been experiencing this, the mobile network, the wireless mobile network over the last 40 to 45 years throughout the different generation. The first generation of mobile network was introduced back in 1980. Since then, there are new mobile generation available in every 10 years. So that's why we are now experiencing 5G mobile network since 2020. So most of the world, like the 5G, has already rolled out. So as researchers, and now we have to think about like how we can go beyond the 5G and what we can do beyond 5G. What should be the 6G look like? Especially this is the right time for us to identify like what kind of technologies to be used in the 6G network. Why I'm saying that? Because the 6G standardization is about to start in 2026. It's not far away, like 1.5 years time. We have to decide which kind of technologies to be used in the 6G network. So when we are deciding like what is to be used as a 6G technologies, when we do go for the standardization, we have to think about like where the 6G network will be used. Especially about the 6G network, we are thinking about available in 2030. So then we have to think about like how the world look like. What is the 2030 world look like? What kind of application available? And what kind of system requirements are needed to satisfy this application? So we are talking about the generative AI-based application or metaverse-related application or digital twin type of application or autonomous driving cars. So there are many applications we are thinking about, and the 6G network has to satisfy the demand of this application. So that is like one of the steps we are thinking, like identify the application and defining the requirement. Then we have to think about what kind of technology is going to be used. So we have seen like everyone is now moving towards like wireless mobile network, or everyone is prefer to use wireless communication, and we can say like the wireless is going to dominate in coming years. So it means like the 6G will be the next communication infrastructure which is providing the digital services for 2030 world. So that's why we have to empathize like the development of 6G has to identify the 6G 2030 world requirement. So we are looking at this requirement, like how we can go beyond the 5G. So there are many technologies has been identified. So for the moment, I would say nobody can say like what is the 6G technologies will be look like. So everyone is proposing their own technologies and saying like how we can enhance the 5G network. So this picture actually I particularly like. So this one coming from the HexaX project, so which is happening in Europe, and we are trying to develop different angles, like 8 different areas we are considering, and how we can expand 5G into the next domain. So some people are working on the performance, radio performance enhancement, and we are working on the sustainability, how we can have energy efficient communication system, and the trustworthiness, how we can improve the security and privacy, and about the connected intelligence, that means how we can integrate AI and other machine learning technologies in the communication system, or we can improve the global service coverage. So there are many areas we have identified, and also there are tons of application or the technologies we are for the moment working on. From those applications, actually, one of the application which is interesting and dominating, and also I find it very relevant to this particular conference. So that is the AI. So if somebody asks like, what is the biggest difference from 5G to 6G? So I think the simplest answer you can say, okay, the 6G will be integrating AI. So if you look at like the 5G mobile network, so in anywhere in the core network or the 5G network deployment, AI haven't been used. 5G standardization, it doesn't talk about how to integrate the AI system. So if you look at the 5G network, the AI will be used in some of the applications, not in the all the applications. But when it comes to the 6G, this will be a complete different picture because AI will be integrated in the almost every section of the mobile network, and almost all the application will be using AI technologies, and also the data collection and the user side will be also supporting this AI application. So if somebody asks like what is the difference from 5G to 6G, you can simply say the AI integration will be the biggest difference. So we talk about like this network AI, that means AI integrated networking, and if you consider about the 6G layers, we don't have architecture for the 6G for the moment, but still we can discuss about the different layers, and the AI will be integrated almost all the layers of the network. But I'm not going to discuss like how the AI will be integrated in the 6G more detail, but I will be discuss more about the security issues when we integrate in AI into the 6G. Okay, so since when we are going to integrate the AI into the 6G network, actually it can have twofold approaches. So because the AI can help us to improve the security in one side. On the other side, AI can bring in a new set of threats, or the new threats landscape will be emerged. So if you look at like the first area, like how the AI can help on the security. So one of the biggest problems we are facing since the 5G mobile network is the scalability problem. So especially we know for the 4G network, we were mainly integrating only the mobile devices. Since 5G, we try to integrate the IoT devices. So IoT devices, that means like we are talking about like billions of devices. When you have like billions of millions of devices, it will be very difficult to manage that kind of network. So we have to go for more autonomous network management. So the autonomous network management can be enabled with the support of the AI system. So this problem is related to the security as well. So when you want to manage like billions of devices, maybe the authentication, access control, anomaly detection, all of these things you can't do with the manual configuration. You have to go for automation. So AI will be supporting this kind of automation. And also like the AI, there are different type of machine learning systems like federated learning, deep learning, split learning. So these kind of approaches actually particularly interested with the 6G architecture, especially like split learning, federated learning kind of scenario is perfectly fit for the distributed system like 6G network. So they can actually give additional benefit. For example, federated learning can provide the additional privacy for the user data. So that kind of approaches are particularly interested like how the AI can bring in additional security for the 6G network. At the same time, we have a problem with integration with the AI because it will be open up a lot of new security threats. So because we know like AI systems are vulnerable to several attacks, for example, like data poisoning attack, inference attack, even privacy attack, membership inference attack. So there are a lot of attacks are possible on the AI system. So we can manipulate the AI system with these kind of attacks. So if you are going to integrate the AI system, AI into 6G network, so you have to make sure your AI system is withstand against these type of attack. So that is like one of the most important aspect to be considered in the security point of view. And also, if you are familiar with the AI Act, so last few months back, the actually European Union has been published the European AI Act that's actually giving the guidelines like how you should integrate the AI system in the critical system. Especially it says like the critical system, if you are using the AI in the critical system management, they have to be trustworthy and they have to be accountable, and also we have to consider the ethical aspect. So this is like one of the biggest challenge we are facing when we are integrating the AI system, how we can ensure the accountability, how we can ensure the ethicalness, how we can ensure the fair usage of the data, and those kind of aspects is very important to be considered. And also the telecommunication sector is a highly regulated environment. It's not like you are using AI in a normal application, let's say text analysis or something, but we have to make sure this AI application is comply with these policies defined by the different regulator bodies. So that's also another area that we have to consider, how we can ensure the AI is comply with the security policies and the privacy policies. So these are the key important research questions we need to be addressed. And another things related to the AI, like when we consider about the 6G network, like where are you going to deploy the 6G AI technologies, and where are you going to have the intelligent integrated into the 6G network or the telecommunication network. So this is where actually interest in this edge intelligence concept came from. Actually, from 5G mobile network, we already have the edge computing. That means like we are integrating some of the cloud computing features already at the base station. So even in every base station, you might have some of the cloud computing capabilities. You can do some kind of processing. But when it comes to the 6G, we are going one step further. We are integrating AI also into this edge computer. So we call it as edge intelligence. That's actually bring up new security threats and also the new benefits as well. If you consider about the benefits, so when we have like a distributed intelligence system, so we can go for, we can easily eliminate the single point of failure, and also we can have some kind of privacy protection mechanism, especially if you use like federated learning kind of scenarios, like where you have the distributed machine learning. You can keep the user data in the local vicinity, so it can provide a certain level of privacy. And also, with the support of edge intelligence, you can detect the attack already at the local vicinity, in the local area, and eliminate these kind of attack in order to prevent these attacks propagating into the other section of the network. And the new security issues which will be arising with this edge intelligence is one of the biggest problem like we will be facing is like, in order to have the better capacity, we have to go for more and more small cell deployment. That means the base station becomes smaller. We will be deploying this base station even inside these kind of buildings. So we will no longer have like, we will have some big base station we will see from the roadside. Not only that, we will have additional base station which will be deployed even inside the campus or inside the hotels in order to provide the coverage. So these kind of small cell deployment are not physically secured. So if attacker can attack these kind of physical devices, they can do much harm because now added AI in these devices. So this is actually explaining like how the federated learning can be attacked in the different areas. So in the distributed machine learning scenarios, so the data collection process can be manipulated with adding the poison in the attack scenarios, and the edge devices can be vulnerable for the model poisoning attacks, like the federated workers can do some kind of damage to the system, and the integration process can be vulnerable for the several attacks if it is not protected from the proper cryptographic method. But that's about like how you will be deploying the AI into different systems in the 6G network. And now I want to discuss another area like how we can make sure the accountability of the AI system, how we can ensure the AI systems are protected against the attack, or not only the attack, and also how we can ensure that they are comply with the policies. So in this regard, actually explainable AI giving a very good tool, and explainable AI is a very good tool for the 6G network. So what is explainable AI means? So the explainable AI can give an explanation like how the AI system is working. See, especially we can identify which kind of parameters has been influencing the particular decision. So the explainable AI can be used in order to understand the black box type of AI system, especially which input is influencing for the output. So the explainable AI we can use for improving the security as well. Actually, I can highlight there are like 4 different ways the explainable AI can be improve the security. So the first one is the explanation for the justification. So I already mentioned that we have to make sure that our AI system are we have to ensure that our AI systems are comply with the certain security policies or privacy policies. So explainable AI can use to justify that AI system is comply with these policies. And the second aspect that we can use is explain to control. So that means like when we are using the machine learning or AI algorithm, maybe you have to train the machine learning model with a lot of data. But explainable AI, if you use the explainable AI, you can identify which features are important, which parameters are important for the training process. You can eliminate the sum of the features during the training process. Basically, feature reduction can be done in a more meaningful way with the explainable AI that can help you to have like a faster training process or improved efficiency in the machine learning model. And also it can be used explain to discovery. So when we talk about the mobile network, so now we are interconnecting IoT devices, now we are connecting a lot of critical infrastructure via the mobile network. So that means we have to make sure these mobile networks are protected against not only the known attack, but also for the unknown attack. So the attacks which haven't happened yet. So we call those type of attack as zero-day attack. In order to detect this kind of zero-day attack, you have to analyze what kind of attack pattern happened in the past, and you have to make a prediction how it is the zero-day attack can be possible in the future. So in order to do that, not only the data which we are available, the explanation can provide additional data which will be helpful to detect this zero-day attack, especially when you are designing new attacks type. Explainable AI provide additional information. And then last area is like the explain to improve. So we know like there are already security mechanism which we develop with the artificial intelligence. We have mentioned like intruder detection system, for example. We can detect the anomalies based on the certain properties, but still they are not up to the 100% accuracy, or even not at the 99% accuracy. Most of the system is still at like 90s level. And we having like a lot of issues with the false positive and false negative scenario. So how we can improve these things, how we can eliminate these kinds of misclassification. So the explainable AI can be a right choice because it can give additional information and which is needed to classify these kind of attacks. So there are a lot of research going on how we can integrate the explainable AI in order to improve the existing AI-based security solution. And how we can integrate the XAI into the 6G network. I think this is like one of the biggest challenge we are facing, because explainable AI is already providing a certain level of information which is needed, which has to be integrated with the 6G network, but still they are mainly used in the application domain, because that's where the explainable AI mostly used. But how we can integrate in the explainable AI into 6G network is it's a critical issue to address. One of the problems like we are facing with the explainable AI is it's very time consuming and research consuming process. So we don't have a lot of resources in the 6G network to support these kind of application. So we have to look for like a lightweight explainable AI solution which can be integrated with the 6G network. So this is one of the interesting research area the people are working on. Okay, so that's about like how the AI can get attacked and what kind of, how we can integrate in the AI into the system. And also, last part I want to discuss is about what the AI can bring into the automation of the 6G network. So already we have started like maybe last 5-6 years looking at like how we can automate the deployment of the services in the telecommunication sector or telecommunication network. So the architecture we are using is called Zero Trust Service Management. Especially we try to automate all the service deployment in the mobile network. in these scenarios, actually, we use this closed loop automation. We observe the network and we collect the data, and then we analyze the data and see what kind of things happening in the network, and we will be deciding what to do about these changes, and then we will do the acting and deploying the services. So this is like the closed loop automation means, and this kind of approaches has been already used in used in the 5G network in order to deploy the services. But with the support of the AI, and we can also automate the security deployment as well. So this is really important when we need to tackle the scalability issues. And the last point, when we are deploying this AI security solution, one of the areas, like a lot of research going on, is to identify the energy efficiency of the security and privacy. So we have seen the AI become popular over the last few years, and it has also increased the energy utilization in the world. So it is very important to make sure that we will comply with the UN goal in order to reduce the energy utilization for the 6G network. But if we use the AI security as it is, or as for today, it will be a problem to satisfy this kind of demand. So that's why the new wings has been developed in order to identify the energy efficient security solution deployment in the 6G network. For example, like moving target defense kind of security solutions, we will be deployed against adversarial AI type of attack. We can consider like security as one of the parameters to define the next target. And also, if you think about like a privacy, quantization, for example, like differential privacy, for example, in that kind of scenarios, when you add in the noise in the privacy protection, you can consider energy efficient privacy addition. So, or the transmission of the data should not increase the energy of the energy of the system. So these areas also become popular, and it's one of the very important aspect of the sustainability of the 6G security. So with that, I will conclude my talk today. So I think the takeaway is like the 6G is going to be the next generation of mobile network, which will be supporting for the 2030 world. Especially when we are deploying the 6G network, it is important to identify the security vulnerabilities. So I have discussed only the AI related aspect, like how the AI can be support for the security improvement, and also I discussed some of the issues we need to address when we are deploying the AI based system in the 6G network. Also, it is important to make sure that the automation of the security solution and also the energy efficiency of the security solution, these two aspects are very important in the 6G network development. So thank you very much. If you have any questions, I'm happy to answer.
Yes, thank you very much, Dr. Madhu Sankaliyanage. And I think for Q&A, although the plan was that after every presentation, we'll be taking a few questions. Yeah. But in the essence of time, you're running short on time, would encourage our guest delegates to please connect during the break time. That's where you can network, socialize, and share your questions with our keynote speakers.
Hello.
Yep.
Hello.
Thank you very much.
Okay, thank you.
Okay. Well, thank you so much for a wonderful presentation. There's a simple question. My name is Dr. Arif Hussain, and I am from Sindh Agriculture University, Tandojam. As we know, this conference is all about artificial intelligence. And one of the biggest challenge that we need to answer in this conference is that, as we know, AI is getting momentum nowadays. We all are talking about AI all the time. Mm-hmm. But if we see in other side of AI, that is very challengeable for us. Mm-hmm. If I am a teacher and I assign some assignments to my students, they go to their home and they get help from ChatGPT or from somewhere else. And then on the next day, they bring that assignment got from ChatGPT. Mm-hmm. If we see the research, like the authors are nowadays manipulating their research papers. A few months ago, I have seen a research paper from elsewhere. And in the beginning part of introduction, it was written that here is your answer. and the reviewers did not see it, and that paper was published. So how do you, this question is from both keynote speakers, how can we face this challenge? Because I think this is a burning issue in AI. So this is another side of AI which we need to address it. So how we can face this challenge in future? Because if we don't face this challenge, then students especially, they will get help from such type of generative AI. So I think our education may suffer.
Yeah, I think this question is more related to the first keynote speech.
Therefore, I said it's from both keynote speakers, if anyone can answer it.
Yeah, in my personal opinion, so I'm a big fan of generative AI because as a researchers we have to be, because that's where we can think about like what new things we can do it. So, and also when you introduce a new technology, actually, as a security researcher, we find it's like a gold mine, okay? So there are a lot of security issues we need to address. So I'm looking from that perspective, and but I think in order to identify like how the AI generative context and those kind of things is beyond my expertise actually. I'm not capable to answer that question, unfortunately. Probably, yeah. We can chat during the coffee.
That should be fine.
Yeah. Okay, thank you very much.
Thank you very much. All right, thank you very much one more time, Dr. Madhu Sankaliyanaga. And of course, I would encourage our delegates, our guests, all the tech enthusiasts, and all the honorable guests who are present at this conference, that in the essence of time, we would encourage you guys to bring your questions to our keynote speakers during the refreshment time and break time. Thank you very much again. Now moving towards our third keynote speaker for this morning's session, that would be Dr. Zafres Christides, who is segment leader at the Worldwide Weather Lenovo. So please put your hands together for Sir Zafres Christides.
Good morning, everybody, and thank you very much for the introduction. Today I will talk about what Lenovo is doing in numerical weather prediction. For those of you who live in this hotel, you probably don't need to worry too much about the weather, but for those of us who live in and stay in different hotels, we had to make sure that we knew about the weather before we made it here. So I want to describe a little bit what goes on in terms of weather prediction and how the process is done. So we have, the introduction is just to give you a little background on how weather is done. The customers that we have in worldwide, weather customers, then some of what we do with the systems and the solutions we provide, then a little bit of our activities in weather prediction, how we customize systems, and how we do research projects, and talk a little bit about the future directions, especially AI, since everybody talks about AI. So you can think about a weather forecast that it's cooked in terms of, well, it's expressed in terms of numerical weather prediction. There are a set of differential equations that take the current weather and advance it in the future. So you have the weather data on one hand from different sources, satellite, different observations, and so forth. And then this data arrives at the data center of any and every weather service. It undergoes in certain quality control. Some data goes out, some data is kept in. Imagine that the data that arrives at the weather service is of the order of terabytes, and some of it is thrown out, and you usually keep the order of gigabytes of data. This data is used to initialize this mathematical model of the atmosphere, and then what we do is we actually do the weather processing. We have supercomputers that actually take these mathematical models of the atmosphere and advance them in weather, in time. Now, of course, out of the integration of those weather models, you have a lot of bits and bytes that don't make too much sense. So in order to make sense out of it, you have to do the post-processing, and see how the data goes, all these weather images that you probably see on television. But the final arbitrator of the weather forecast is your weather forecaster. Every weather service has a weather forecaster who looks at these numerical weather models as tools and finally makes his own decision on how the weather is going to be today and tomorrow perhaps. And of course, to take it one step ahead, it's about the artificial intelligence. This weather forecaster has his own intelligence and own experience by looking at different weather situations of the past and taking the information from the weather models, which are used as tools in his tool bag, and advances them into the future by telling you the weather. What we do with artificial intelligence is we basically replace the intelligence of the weather forecaster with these neural models, neural nets, where we actually get all these data, we train these nets so that the actual forecast comes from computers. Now, a little bit of our weather customers, we separate them into different categories. Of course, every weather service has their own supercomputers. These are our customers. We put them in operational weather centers where actually have the mission-critical applications, the weather models that predict the weather. We have a few large ones. We have a few small ones, but mainly these are operational centers. But we also have research centers that will provide equipment for them. And the research centers is also important applications to actually do innovations and figure out new things about weather research. So we have customers in just about every other continent. And we address the customers in different categories. There are some very small customers that have needs that don't have local expertise. So we call them as $1 million and less than $1 million in terms of equipment to be purchased, medium and large customers. And our activities are basically to develop and customize supercomputers for them and actually deliver supercomputers to customers that don't really need any local expertise. They have their own experts. But for smaller customers that don't have the numerical weather prediction expertise, we partner with solution providers where we actually not only install the hardware, but we install the application software. And we also do some local research. Of course, we are a computer company and we don't have all the resources to do weather research. We just have to develop partnerships with universities and the industry. And we've done some, and we have two of our largest customers in the world today is the Korean Meteorological Administration, where we roughly have 400,000 cores in terms of the Intel processors. The Environment and Climate Change Canada is another weather customer that we have, over 300,000 cores. And these are our, NCAR is one of our partners, numerical weather prediction consultants and so forth. They're all helping us serve individual weather services around the world today. Now, if I can describe to you what goes on in weather prediction and the systems that we actually produce for our weather prediction customers, the smallest unit that is needed for that are the processors. And we deal with both Intel Xeon processors and AMD EPYC processors, the latest technologies. And these processors go into motherboards, motherboards go into individual nodes, and then nodes go into racks. And racks basically have these nodes interconnected with special interconnects, and we have storage that needs to go in there. And at the same time, we need the system software that make all these supercomputers usable. Schematically, if we want to show pretty much what happens, we have the custom solutions, and we have a system that we design where we have different compute nodes. We have special line nodes that are for certain tasks like pre-processing and post-processing, login nodes for people to log in and do compilation and do other tasks. All these nodes are interconnected with a high-performance interconnect, and we have storage that actually is connected with the rest of the nodes. This is high-performance storage, and users can actually log in into these login nodes from the campus or whatever offices they have. And sometimes we need to, and we have customers that have dual needs. One of them is to do operational weather forecasting. The other one is just to do research. So we provide dual clusters, and these clusters are connected with the same interconnects. And we have near and far storage that actually serves both clusters. And we also have systems for backup and so forth. So this is schematically how all these nodes are connected together, how they are managed, how storage is connected, and how the whole thing works. Now, we have several customers around the world. The Malaysia Meteorological Department was one of our first customers that actually went in and installed a system which by today's standards is very underpowered. They're in the process of getting a new system these days. They procured for one. We installed also the application software for that, which is the weather model. They use the WRF as the weather model, and we installed all the software for that. And again, this is not even the first generation of Intel processors. The Argentina, in 2018, we installed a system based on the first generation Intel Xeon processors. And of course, they upgraded the system very recently, which is a part of the top 500. We have the system. In fact, I just came back from Saudi Arabia, where we work with the Saudi Arabian, the National Center of Meteorology, where we not only we installed the system, but we installed the software. They have several systems, first generation, third generation. They do research in weather prediction, they do flood prediction, and so forth. So I'd like to give you a few examples. Actually, we have installed several models for the National Center of Meteorology in Saudi Arabia, WRF being one, and a few other models. And we also have a dust and sun prediction model, which is the WRF Chem, to predict the dust storms that they have. We installed wave and ocean models as well. And we installed a system which is based on the AWIPS. AWIPS is a graphic system that is used at the National Weather Service of the United States that integrates all the graphics, all the images that are generated from these weather models and superimposes satellite and radar data. This is a very useful tool for the weather forecasters to actually interpret the condition. And this is some of the work we've done. It's published at the Weather and Forecasting. It just appeared in 2024. Now, recently we added a new system that works on the top of the weather forecasting system. And this is a flood prediction system that they have, where we actually get the data from WRF. So the atmospheric model is connected with a hydrological model, which is CREST. And then that model basically calculates how much rain falls and how much rain is absorbed by the sand or the ground. And then some of that rain would basically run over, and we have a hydrologic model, the HECRAS, that actually moves the rainwater around. And if it happens that this rain that is produced in different areas goes over a certain level, then a warning is being triggered, and the warning is done. And in fact, we don't have time to talk about it, but there was a very catastrophic event 2 years ago in November of 2022, where we actually were very successful in predicting a flood that occurred in Jeddah, which is where the National Meteorological Service is based. We published the results from that rain event in the Water, its journal, and at the same time we nominated the National Center of Meteorology for the HPC Wire Awards. So they won the best use of high-performance computing in response to societal plights. And so they carry this award with pride. And this is, again, the publication we had about that event. Now, of course, we deal with a lot of benchmarking. We have a large group that actually deals with running all these kind of models And of course, you probably know, most of you, that weather models are like religion. Every weather service wants to have their own weather model. Well, we have experience in dealing with all these models, but we have a lot more experience on the weather research and forecasting, which is a WRF model. And it's public domain model. Just about everybody uses it. There's a lot of tools that have been developed and a lot of publications and a lot of debugging is done. Anybody can download it. It's multi-purpose, multi-used. So we just basically use this. We find this weather model that is being used extensively in Asia Pacific and even in South America. We have around 150 years of men experience, 150-year men experience in terms of benchmarking and running all these applications. So we run a very large group of high-performance computing experts on weather. We also do some research using artificial intelligence, where we actually take some of the radar images and we pipe it through an AI model. For our purposes, we use the convolutional transformer method, where we actually take the radar images, let's say, from 3 hours and beyond, and we just like to produce forecast or how these images are moving or are they going to move into the future. So this is used for nowcasting. In fact, they even use it at NCM today. There are different methods around. Google is using one of them. So we're just doing the convolutional transform method. We have a publication about that as well. Now, about the future directions, everybody talks about AI. We need to talk about AI. It's a modern subject. So we'd like to basically answer the question of what are the GPUs. Today, most of our users on weather, they don't like to use GPUs. They use actually traditional processors. But everybody wants to know how GPUs are used in numerical weather prediction. So my view, and most of the weather forecasting offices, their view is that porting of all these weather codes, there are traditional weather codes based on standard format, Fortran, on GPUs is still very slow. And the main issue is the language compatibility issues with those GPUs. And also another issue is the upgradability of these codes. So every time, let's say NCAR is issuing an upgrade on WRF, they issue the upgrade on standard Fortran. Somebody has to go and move it into, immediately when there is a new version, move it into GPU language. So that's not very efficient. Now, artificial intelligence on weather using GPUs is very trending. I've seen publications basically dealing with AI and weather. In the past, they were used to do nowcasting, and nowcasting means that you do the forecast from now to 3 or even 6 hours ahead. So that's an easy way to do short-range predictions. It's proved to be quite accurate, and it's much less expensive than using very large supercomputers. Now we tend to use also artificial intelligence and GPUs in other areas as well of numerical weather prediction. But one of our recent experience with the weather models is that basically these are computer codes that actually take data from the memory and just bring it in for processing. So the main task is how to bring data from memory to the CPU. So there is, all these weather models are what we call memory intensive, or just basically the memory traffic is severe. So what we experimented with is with CPUs that actually have memory near to the processor, not in memory banks, but actually near to the processor. And we found out there is a tremendous improvement because of the bandwidth that is actually facilitated by these processors. So to summarize, we do have at Lenovo several focus areas. Again, we are a computer company, so our main strength is how to customize and how to build supercomputers. But the objective is also to understand the science area behind weather, for this example. and we are encouraged to collaborate with research institutions and universities because we can actually sharpen our skills. We remain basically very aware of what are the newest technologies. We actually participate in joint activities, do a lot of publications, but our strength is hardware and commercial solutions. We port and optimize all these weather codes on our supercomputers, and we actually do analytics. But our core strengths are high-performance computing, supporting our customers, and actually customizing, tailoring systems for their needs. We have mutual benefits for that, and we continue to do that successfully. I'd like to thank you, and if you have any questions, I'll be more than glad to entertain you. Thank you.
Thank you very much, sir. Thank you very much. We're short on time, so that's where we're not taking questions. Thank you.
Thank you.
Thank you. All right, thank you very much, Zafiris Christodis. One more time, a huge round of applause and a huge thanks to all of our keynote speakers, starting off with Dr. Aga Ali Raza, then we had Dr. Madhusanka Lianage, and lastly, we had Zafiris Christodis. Now, ladies and gentlemen, it's time for a quick break. We'll be taking a quick break of 7 to 10 minutes, and I would request our delegates, our guests, and tech enthusiasts to take a quick break, and right after that, please do join your sessions and conferences at your earliest. Once again, my name is Rizwan Qureshi, and it was an absolute honor to host this part of the conference. Please have a break, enjoy yourself, and right after that, please report to your sessions. Thank you very much.